Can you hear me? I'm going to try again. How's that? I think I broke it. How's that? All right. All right, thank you. Thanks for the introduction. So I'm not at the beard and mustache contest. Is that what it is? That's next week. Okay. Thought it was now. For those of you who came here to hear me talk about birds, you'll be disappointed. I'm not going to talk about birds at all today. I do other stuff besides that, and sorry. I'll be talking about hot moments in conservation, and I think the first thing I need to do is talk about what conservation is and what it means for me. A definition I like about conservation is that it's a concern over careful use of natural resources in order to protect biodiversity. So biodiversity is in there. It's pretty important. There are many reasons to protect biodiversity. There's ecosystem health, ecological services that biodiversity can provide us. There's economic values that we can attach to some species. For example, tourism at the spectacular reefs in some tropical regions. I'm co-teaching conservation biology next semester, and we'll talk at length about all these values of biodiversity. But I don't like to pigeonhole the values of that into these utilitarian views. To me, there's something else about biodiversity. There's something uplifting. There's something that's more intrinsic about the species themselves that I find important. And it's hard to describe, it's hard to explain, but I find a lot of value in something like that. And here I went talking about birds. I didn't think about that. These are snow geese in New Mexico all lifting up at once, tens of thousands at the same time that you can see in winter. It could be a prairie with a lot of native species all in bloom at the same time, a robust prairie with few invasive species. I find that particularly uplifting to see. Large events, large phenomena, natural phenomena like migrations. This is the caribou migration in the northern part of North America. We have our own Serengeti in North America, and it looks like this. I haven't seen that, but just knowing it's there is important for me. Who's this? Anybody remember who this is? Yeah, Aldo Leopold. You guys should have known. You've taken my classes, right? Should be a soundtrack here. Is there sound for the video? I'm going to try again. There we go. One manifestation of biodiversity is a soundscape. This is a soundscape that Aldo Leopold could hear from his cabin in Sauk County in Wisconsin back in 1941. At the time, there was very little intrusion from motors like generators and cars and trains and planes. And so this is probably pretty close to what he was hearing at the time. And there's a certain value to that that's hard to describe in terms of, say, utilitarian or economic value. Still, I feel like it has a lot of value to a lot of people. By the way, Aldo Leopold was the founder of wildlife management discipline I come from, and also one of the fathers of the ecological land ethic, way of seeing natural resources that I think has a lot of value. Talking about birds again. Here I am. Talking about migration at night. All these songbirds are singing by Leopold's shack in Wisconsin, have to fly down in winter, and that's what it looks like at night on our weather radar. All that blue there is birds, a sheet of birds, millions of them flying south. There's a little bit of rain here. Everything else is birds flying. Migration of butterflies, pretty spectacular here in late August, early September. Big breeding aggregations of northern gannets. This is on an island in the St. Lawrence Seaway, St. Lawrence Estuary in Quebec. And when I look at something like that, these birds, there's about 60,000, 70,000 pairs of gannets here, the largest breeding colony in the world. All these birds spend their winter out at sea in the North Atlantic, all the way down to the Gulf of Mexico, and they all congregate at once over a few weeks in the summer. What if something happens right around the waters of Bonaventure Island like that? What if oil spill happens there? It seems to me like there's a risk here that's very concentrated in time over those first few weeks. And when I think back about these butterflies, they all winter, all of them, in one slope in New Mexico. We've seen pictures of that, all congregated into trees, right? It seems like the whole population is very vulnerable for that very short amount of time. And that's got me thinking about time, about risk and time in terms of biodiversity. And that's what I want to talk about today. So temporal variations, either in threats to conservation, and that's the first part of my talk, or in opportunities in conservation, and that's the second part of my talk. The first part, I'm talking about South Berwick, Maine, not South Berwick, England, if there is such a thing. There's a Berwick. I'm not sure there must be a South Berwick, right? It's a small town. Looking from the top of Mount Agamenticus in southern Maine, it looks like a carpet of forest, but it's full of roads and houses distributed everywhere there. It's actually a section where there's not many roads for being so close to being right on the I-95 corridor there. You have, just to situate you, you have Portsmouth, New Hampshire here, Kennebunkport, the Bushes compound somewhere out here, and then Portland, Maine. And we're not far from Boston. A lot of people in that area, a lot of development, but also a lot of natural resources, including these wetlands, which are called vernal pools. They're small pocket wetlands that actually dry out at some point in the summer and fill back in the winter. These wetlands are rich in resources like invertebrates, tadpoles, aquatic vegetation, and they're a resource for these guys. These are blanding sturtles. It's a state-listed species that might be soon to be federally listed. They occur in New England on an arc going from Maine through New Hampshire and Massachusetts. And they rely on these wetlands. They're really long-lived animal, 70, 80, 90, 100 years. They don't start breeding until they're about 20 years old. They breed once every other year, and they breed like that until they're in their 80s at least. And so the population can grow very slowly because of that. And they've evolved to be able to live a long time and to be able to reproduce for a long time by having this domed shell that's pretty solid and prevents predators from getting at them. One thing, though, that they didn't evolve to do is to protect them from roads and cars, right? And these turtles travel a lot over their summer, their active year. They go from wetland to wetland. These little pocket wetlands, they move from one to another over the entire summer. They can put in 20 miles over the course of the summer, just moving like that. And in the process, they cross roads. I studied those animals when I was doing my PhD. The main tool we used was radio telemetry. This is a transmitter that's glued in with acrylic, and this is the antenna that wraps around. There was different ways of putting it on. That was one of them. And then we tracked that turtle. We tracked about 50 of them over 3 years with a little antenna, a little receiver, and we just walk around and try to follow them, try to keep up with them. And this is what it looks like. This is a fairly typical track of a male blanding sturtles. It started out here in a deep pocket wetland that didn't dry out. And then over the course of the summer, it just went around looking for little wetlands, looking for females, and moving around the landscape and going back to that same wetland. In the process, it crossed roads 1, 2, 3, 4 times, right? And this is a fairly busy road here. I'm not going to go into traffic volume numbers or anything, but it's a busy road. You look on both sides when you cross. So there's a risk to the population that's very high due to roads here. The roads are short-circuiting the evolutionary strategy that these turtles evolved. So it makes them, a slight increase in mortality to the roads can make the whole population decline. What we did with that project, we identified areas where the risk of road mortality was highest. I'll spare you the details, but we, at different spatial scales, this is just one of the spatial scales, we looked at where on that busy road are the highest risks for a turtle in terms of at the population level for crossing the roads, and it turned out to be here based on a whole bunch of factors. So it was giving us some spatial idea of where that risk was, right? We call those hotspots. So a location where a threat or an opportunity, a process operates at a higher rate, we call that a hotspot. Now, think back about those gannets being in one location for 2 or 3 weeks, 4 weeks, and think about those butterflies. A time period when a threat or an opportunity process operates at a higher rate, I call that a hot moment. I got that term from the biogeochemical field when we were talking about nutrients and pollution moving through the soil and along with water. And I tried to introduce it to the world of conservation, and it's picking up slowly. Not fast enough for you to Google it safely quite yet, especially I tried just this morning, and it's not quite there yet. So we haven't overwhelmed the other uses of hot moment yet. I'm not sure if we ever will. But, so don't keep trying. I won't. Not here, anyway. So that's the question we're looking at. Is there a time of the year when the road mortality risk for turtles is higher? And I'm not talking about the risk for one individual turtle. I like individual turtles, but I'm concerned more about the population itself. And that means different questions if we're talking about individuals versus population. And you'll see what I mean in a minute. If you ask people that know a little bit about turtles, they'll say, oh yeah, during the nesting season, that's when the females are out and about looking for a nest. That's probably when it's highest. Oh, fair enough. Let's examine that a little closer. The factors, the variables that I looked at were the movement length. So the longer the movement over land, the higher the risk, I would assume. Separate that between males and females. Also, how many of the females and how many of the males are moving? What's the proportion that are moving? That's also important. And I assume traffic volumes make a difference, right? Is there a temporal variation in traffic volume? So I was going to look at that as well. First thing is average daily movement length just for females. And we noticed that there is quite a difference over the time, over their active period. This is from April when they emerge all the way to October when they go back for their wintering, their wintering lack of activity. And what you see is very clear variations. This is based on 3 years of data, and I think that's 27 female turtles. And the most striking thing here is this peak in July. The nesting season for turtles, for those guys, is late June, right around here. So this peak is actually higher. Once they've reached the nesting grounds, then they move a lot. They take off, and they move elsewhere. So that peak is actually not during nesting season. Okay, interesting information. We did that. This is what you just saw for females. We did the same thing for males. No such peak for males. They seem to have a fairly consistent summer activity. Late July, early August, it seemed to redistribute themselves on the landscape quite a bit. There's some large error rate here because we have a lot of variability between the 3 years for those periods. Proportion moving. Females are the little triangles here. The largest proportion of a large proportion of the females are moving in June and July. And for males, it's fairly consistent. And then traffic volume. Southern Maine's a place where there's a lot of tourism for the beaches. This isn't close to the beaches. Well, it's relatively close, but it's not right at the beaches. So I wasn't sure if there'd be a signal from tourism. And there's clearly a signal June, July, August where traffic volumes are higher. This is the annual average. And it dips below that average in the winter. So high school students are out of school. They drive more. They drive around to their summer jobs. There's tourism. There's all kinds of things that make that peak there. But that peak is more in August, less in July, and clearly not in June when nesting occurs. So now, is it as clear when the hot moment and risk is? Not so much, right? So we took an approach looking at using a type of analysis that helps us project populations forward. And I'll talk to you a bit about that in a second. First thing we did, we cut the whole April to October to November period in 2-week sections. And for each of these sections, we came up with values for each of these variables for males and females. And we integrated that in a model of risk of being killed while crossing a road. So it's this little model that's based on probably being killed for one road crossing. And the variables are in here. N is the traffic volume. A is the width of the carapace, of the length of the turtle, essentially. So the bigger it is, the more likely it is to get hit by a car. And V is the volume of vehicles that go by. So you parameterize all that. And I was able to come up with, it's more complicated than it sounds, but eventually you come up with mortality estimates that are due to roads, that you can tack on the normal natural mortality rates that you might have, that we know from studies of that species. And we integrate that in something called a PVA, a Population Viability Analysis. So I'm going to open the parentheses here and explain a little bit what a PVA is. It simulates the growth of population using empirically derived population parameters. So imagine you have a starting population of turtles, okay? You've studied them, so you know their average clutch size, you know their fecundity rates, you know the survival rates of different age classes, different sexes. We have a lot of information about that we got from that study and other studies. Then you project it in time, and you assign each turtle a transition probability that it will either live or die, okay? And that transition probability is based on the studies we've conducted and from the information that I had for road mortality. So for 1 year, each turtle has a probability of dying or surviving that's consistent with what we found, the empirically derived parameters. And then we have another transition probability to figure out which one are going to reproduce, right? A certain number are going to reproduce and have a certain number of offsprings, and based on the estimates that we obtain. And this is not deterministic. This is stochastic. So one run of the model will have certain probabilities. A second run will have different probabilities. A third run, etc. It'll go on like that. And on average, if you add up all these events, they'll coincide with the transition probabilities we had at the starting point. So you understand that it's not deterministic. It's a whole bunch of simulations that are stochastic, for those of you who are into modeling. So we do that, and we project these events for 50 years forward, okay? And we do it 500 times for each model. Now, can we look at 50 years from now and say, okay, the population size is going to be this? No, has no absolute value in terms of results, but we do it for each of these 2-week period and compare the effects of proportion of movement length, of traffic, and all these things for each 2-week period. And the strength in this is in the relative value that you get at the end of your 50-year simulation, okay? An example, this is from a different study, an example of a result from a population viability analysis. This is for some foxes. Can be something like this, where over 100 years, this is the projected population growth for one population versus the next, and this is the uncertainty associated with it. And this could be the probability of extinction for that population over time. It decreases here. So it's a little bit like that, what we're doing with turtles, except I never show these results because that's not what this simulation is about. Those are just absolute numbers that mean nothing in this case. What is important is this, though. R in this situation is the growth rate of a population. A positive R means the population is increasing, a negative R means it's declining. And the value here is not so much in the numbers that you have, but in the relative position of each of these points. A low R means a greater effect on the population. So think of it that way. So you have each 2-week period from April to October, and what you see is that the risk to the population, I'm not talking about the individual, but the population actually increases as R decreases over the summer. It's pretty high during nesting season here, but it's actually highest in July, the first 2 weeks of July. That's where the peak in risk is. This is the hot moment for that population right there, okay? Do you understand that? All right. Now, why is that peak there? What drives that peak? So we did some retrospective analysis and looked at the different factors, and the strongest influence comes from movement length by females. This is an R, your classic statistical R. This is a different R. It's unfortunate. I'm sorry, but it's the same. So the R, so the degree of correlation is highest for movement length for female. Females tend to have long movements in early July, and that's what puts them at risk. They cross rows more often. On top of that, they're females. The mating system these turtles have is such that you could remove half of the males that are out there. You could remove 3/4 of the males that are out there, and they'll probably still do fine, right? They only need a couple males in the area that are close enough that they can reach them. Females can store sperm for 6 months, so they don't need to run into males that often, right? So it makes males very unimportant in that landscape. So this is the key factor right here. So that helped us identify that hot moment for that population. So sure, many seasonal factors influence the risk to populations. We have to be able to identify these factors. Viability simulations, which is what I call my population viability analysis. Reviewers won't let me call it a PVA because the way the absolute results are not meaningful, right? So I gave it another name just for that. It's a PVA. And so if you have mitigation efforts, try to prevent these issues, temporally explicit mitigation efforts will be most effective in late June and early July. So what kind of temporally explicit mitigation efforts are we talking about? There's different ways. If it was a really endangered, like highly endangered species, and there was a lot of will to prevent trouble for that species, we could talk about things like road closures, right, for a 2-week period. That's out there. But for now, what we do is we install these road signs out there that are hinged, and these road signs are closed most of the year. People don't notice them. When that hot moment arrives, send a crew, just flip open those signs. People are, oh yeah, that's right, those turtle signs, and hopefully are more aware of what's going on the road. And we coincide that with an annual press release that explains what's going on, and so hopefully it makes people a little bit more aware of what's going on. So this is a temporally explicit mitigation measure to put in jargon, basically. All right? So we live in a country where we have the kind of the luxury to be concerned about the comings and goings of individual turtles, right? It's not the case everywhere. I'm belittling a little bit the issue here, but you get the idea. And we're in a place where biodiversity is actually not that high if we compare us globally. By far, most of the biodiversity in the world is concentrated in these places called hotspots. Now, we're talking about hotspots again at a different scale, at a much larger, a global scale. These are where our biodiversity hotspots are. Actually, in the U.S., we have one in California, the California floristic region. What's so rich about California in terms of species? Is it the birds? Is it the mammals? What is it? Plants. Really, I said floristic. That was the key right there. Really high diversity of plants. Another place like that is the Cape region in South Africa, very rich in plant species. You have the Mediterranean region here. You have Madagascar, of course. Everybody's seen the Disney movie, right? A lot of important locations like that. Now, because of that, because of maps like that, because of knowing where diversity is, we've gotten pretty good at focusing conservation where biodiversity is high, where species richness is high. And we can come up with reserve designs. We can come up with conservation areas and figure out where they should be positioned based on a whole bunch of variables, whatever it is. People have been doing that for about 20 years now, and have gotten pretty good at it. And this is an example here with deciding where protected areas should be. So this is kind of the bread and butter of a whole class of conservation biologists out there. So we know where to focus conservation pretty well. But we don't know really when. We kind of assume that once we're done with that paper, we publish it. A couple of years, there'll be a national park or protected area over there. And then we know it doesn't happen, and we wonder why, and we're sad about it. And then we go and make other pretty maps, and not much happens. And we don't really question ourselves about why. So what is it that certain moments in time we can see a lot of effort that pays off, and we see new areas, we see protected areas. We see the conservation I'm talking about here is not about helping turtles cross the road. It's at a broader scale, usually protected areas where we have goals for it. Doesn't mean that it's a preserve where nothing happens, but how about that? It's an area where the main focus, the main objectives are conservation for that area, okay? There could be still villages there, there could be work, it can be a working landscape, but the main focus is maintaining that biodiversity. So this is where I'm talking about hotspots, hot moments now, but at a global scale, much larger spatial scale. So you've seen the title. Anybody has a clue of what happened in 1961 in Tanzania? What was that?
You were born that year.
Really? Oh, oh. You're about 15 years wrong. Anybody else has a nicer hypothesis? 1961. No? What was that? Born free? I don't know. I was just one that year. I don't remember.
Independence of Tanzania.
Independence of Tanzania. There you go. The end of British rule in Tanzania. And we'll see why that matters in a minute. So what we're wondering really is are there windows of opportunities where conservation efforts are most successful? When does it happen? When do those pretty maps become reality? And if they are, when are they? When do these occur? So this is a project I worked on with a group of people from different places and with different expertises, and we looked at that. And it was really exploratory work. Nobody's looked at that at all before, so it was very exploratory. But we were wondering, just over beer chatting, is it during a country's economic development when things are going well and high GDP, and now they can spend money on conservation? Is that what it is? Is it when governments change? Is it when there's a big threat, a big shift in the conservation threats? We didn't know. So we took what's called the World Database on Protected Area. It's a database that's created by the United Nations Environment Program, and it keeps a really good database of all protected area. And here we can see Letchworth State Park, the Adirondacks, small and large reserves all over. And it's for the whole world. It's actually a really good database. And with that, we selected a range of reserves, because there's all kinds of reserves, right? We selected the top 4 types of reserves. Strict natural reserves, areas primarily managed for conservation, natural monuments, and areas are managed for habitat or for species. And then we could go on with lesser types of protection, and we stopped there. And for each of the countries that we used in the analysis, we looked at their relative area and the count of protected areas. So how much acreage, if you will, how many square miles, square kilometers, and how many units, how many areas were protected per year, because it's a time analysis, temporal analysis. Also for little windows, that like a sliding window for 3 years that would calculate the average for that those values for a 3-year window, and then for a 5-year window. And then we looked at thresholds. How many countries set aside more than 50% or more than a third of their total protected area within those time periods, those 3 time periods? Do you understand the analysis we're doing here? All right. We also looked at something called a Gini Coefficient, and several of you are familiar with that. Gini Coefficient? A little bit. And in what field is it used usually? Yeah. It's a measure of inequality. It's used usually to look at countries and the level of inequality. I don't know if it's in revenue per family or what measure it's used, but that's mostly where it's used. And we kind of borrowed that and we used it as what it is. It's an estimate of statistical dispersion. And what you would expect if you had a Gini coefficient of 0, the area protected each year is constant. So over time, you would have a constant increase in area protected, or a constant decrease, I don't know. If you have a Gini of 1 at the other extreme, the entire protected area for that country was created in 1 year. You understand the idea? So looking at those numbers will tell us right away if we have things that might look like hot moments. And this is what our Gini coefficients look like. This is the number of countries in the analysis. Look at the scale here. Starting here, Gini coefficients of 0.9 to 0.95 and everything above. Most of the countries have created most of their reserves over only a handful of years. Okay, so that was the first clue that, yeah, there is a strong hot moment effect going on here. And so this is for area protected, and this is for count. And we do both because sometimes if you create one area that is so large, it might overwhelm the signal and not take into account other small reserves you could have created over the years. So we do both, and the signal is similar for both ways to analyze it. So we looked at that a little closer. This is cumulative growth curves for the total area protected, and we have the same for counts, but I'm not going to show it here today. It's very similar. This dark line is the global average. So we see actually it's fairly constant, except there's definitely a peak here in the 70s. But what you see here is individual countries really follow like a step-like process. So there's moments where, boom, you have huge increases all of a sudden, okay? And we weeded out of that analysis all the countries that have very small numbers or very small area of reserves. We're dealing with the big players and the conservation real estate here. The top, I'm not sure how many countries are in here, but we're talking about somewhere between 40 and 60 countries, okay? So Luxembourg is not in there, and Liechtenstein is not in there, and San Marino is not in there. Let's look at it a little bit more closely by group of countries. This is Africa, so terrible choice of colors if you ask me, but nobody asked me. This is Tanzania right here, so it's this line here. This big chunk here is Serengeti Park. It's a huge park. It's something like 4,000 or 5,000 square miles. So gigantic park right here. So that was created under British rule fairly early, and then nothing happened for a long time. And then all of a sudden, stuff starts going on. And from late 50s, about here, to early 60s, something happened here. And you can see a similar story for most of these African countries. And you guessed it right, that peak and park creation started before the end of the British rule, but really towards the end, 1956, 1957. Something was going on where there was national pride, where there was a desire to showcase things, and I'm reaching here right now. Let's look at those motivations. But, so around 1961, which was when the country officially became independent, is when that stuff happened. And this is one case where Tanzania became independent peacefully. There was no civil war associated with that. So a lot of parks were created right around that time. So we're talking about 30% of Tanzania, not 30% of protected areas. 30% of the whole country was set aside around the end of the colonial period in 1961, including this park here, Mikumi National Park. Another group of countries, the former Soviet bloc, we start seeing a big increase. It depends on which country we're looking at, but it's definitely step-like. Seems to be like this curve is steepest around here, right? And if you look at the actual parks for each of these countries, of course, it coincides with the fall of the Soviet Union. So late 80s and early 1990s is when things started speeding up. Most protected areas were established late 1980s and early 1980s after the GDP had been cut in half for a lot of those countries. So it doesn't look like it's an economic thing. It doesn't look like it's, yay, we're wealthy, we have the luxury to think about that. Boom, let's create those parks. It was an institutional shift that was major with a lot of consequences on society, but that ended up helping with these conservation goals. In Europe, I like this one, boom, 0 to almost 100%. This is Greenland. Greenland has a park that's over half of Greenland. Big chunk of ice, if you ask me. But so that's what you see there. It's probably not just a big chunk of ice, I know. But, you see, Italy here is interesting. Over here with this huge increase here, it looks like half, right? What happened here in Italy? Oh, problems with the... Italy voted in what's called the Framework Law on Protected Areas in 1991. It's not something that happened in 1991, boom, it happened. People have been working towards that, pushing that for a long time, and it happened in 91, and the number missing here is 17 new national parks were created in a single year, including this one in central Italy. I forgot the mountain chain there. What's it called? Yeah, Apennines, that's right. So Grand Sasso. That's where they built this huge tunnel. I don't know if you remember seeing that in the late 80s. Huge, long tunnel, and there's actually physicists. You should know about that. There's part of that tunnel, there's a particle accelerator. Yeah, so it's like there's two. There's the eastbound lanes, the westbound lanes, and the light speed lanes. Or there's one of them anyway. And that's where they figured out that you could go faster than the speed of light. Yes. And it was not true. I think it was some of those guys, that opera group, right? All right. Germany is really interesting. So, okay, we're talking about institutional shifts. We talk about new laws voted in. During the last meeting of the East German cabinet, the very last meeting, 2 weeks before East Germany was going to be melded into Germany, today Germany, this guy here had been working for years, preparing plans. If somebody asked him, how would he protect natural resources in Germany, right? And everybody's like, yeah, like somebody's going to ask you, right? 7% of Germany was protected at the very last meeting of the East German cabinet because of that guy, because he was ready, because he had maps, because there was the right opportune moment to talk to people and to make it happen. And he was there, and he was ready, and it happened. In Italy, I don't know what happened. See, this is where historians have to pick up where we leave off and look at what was the context at the moment, who were the players, what are the reasons behind all that. Sometimes it's a little more clear-cut, and it's simple enough that we can take a peek at it. North America, let's look around here a little bit. United States is this line here. Boom. What happened here? 1980. Jimmy Carter happened in 1980. Yes. And some people are happy about that. Some are not. So what did he protect in 1990? There's a couple cues in there. So in the United States, 58% of the protected area, 58% of the protected area in a single year. Who's this guy? And if you can't figure out who he is, look at this guy's beard. It's Alaska. I don't know who that guy is, but I bet he was from Alaska. 1980, looking like that. This is Ted Stevens, a longtime senator for Alaska. Is he in jail now? No, he's dead now. Alaska National Interest Lands Conservation Act, 1980. Over 100 million acres were protected in a single year. All these areas in blue. And you might say, oh, yeah, well, it's middle of nowhere, right? Like, what was the political cost of doing that? There's a lot of mining and oil and gas activities around those areas. So it wasn't a simple thing. There was a lot of challenges to that. So that's what happened here. So that was interesting. So globally, out of 167 countries, 44% set aside over half the protected area in 1 year. 44%. 60% set aside over half of the protected area in one 5-year window. That's a lot of people. It's a lot of countries. And 49% set aside over 33% of the protected area in 5 years. And I did this by count so that you don't think it's one big park that created this shift. It also counts. The signal's a little weaker with counts, but it's there. It's definitely there. We also looked at whether or not hot moments happened right after international conservation summits. And God knows there's been a lot of those in the past, starting at 1972 World Heritage Forum, some of them specifically for national parks. And later on, now we focus more on efforts on climate change. But there's been a lot of these important forums. So what was the signal after those forums? Was there a bleep? Was there a hot moment? None. Zero. Now, there could be some delays, some lag times. There could be something going on here that historians could look at a little more closely than our crude assessments. So our conclusions for this were there's strong evidence for hot moments for conservation. There's definitely some strong moments. Conversely, there's some chilling moments as well. There's some times where conservation areas went down in the percentage. During the Khrushchev years in Russia, he reclaimed some of these national parks. So that we have to be aware of those as well. What can we do with that? Conservationists in country might be able to monitor the political climate towards conservation. What if we do a survey every year and ask local conservationists how's it look these days, and keep track of the political climate for things like that, political receptiveness conservation. And we should always be prepared to capitalize on hot moments when they occur, right? When the Arab Spring was starting, my colleagues and I were wondering, is this one of those times? Are we seeing one of those times? It's too early to tell, and I bet most of the time we won't be able to tell till much later. But we should be ready. We should have maps ready. We should have people in the country that are aware of where the resources are. They should have plans to help make progress on those fronts right at those critical moments in time. So with both of these projects, what I'm trying to show is that we have to consider temporal variations. We've been considering spatial variations a lot, and we also need to think about temporal variations in risk and in opportunities when we talk about conservation. And that's the message I'm taking to colleagues in different forums than this, obviously, but where people might be able to apply that to their thinking about conservation. With that, I'd like to acknowledge a whole bunch of the collaborators that are co-authors on the papers that came from that. And I'd like to thank you for having me